spinal cord injuries are among the most debilitating conditions, drastically altering the lives of those affected. Paraplegia, resulting from severe spinal injuries, presents lifelong challenges that are hard to fathom for those with full mobility. However, recent advancements in medical technology are offering a glimmer of hope. Scientists have developed a groundbreaking spinal cord implant that stimulates muscles, potentially allowing paraplegics to regain movement. This innovative technology, which has already shown promising results in clinical trials, could revolutionize the treatment of spinal cord injuries and offer new possibilities for recovery. Using our legs to perform daily activities is something that those of us who are fully mobile take for granted every day. Unfortunately, those who have suffered a full spinal cord injury have had their lives changed forever. Being a paraplegic presents a set of lifelong challenges that the rest of us never really consider. But what if there was a way to reverse this condition? Well, a team of scientists has made the first tentative steps towards a feasible solution. In this episode, we'll take a look at this breakthrough. This technology is so precise that immediately after the surgery, the patient can walk and stand. In a clinical trial, 3 men were recently given the chance to walk again thanks to a new technology showcased in the journal Nature Medicine. The system involves a spinal cord implant that stimulates muscles, enabling them to move again. Grégoire Courtine, a neuroscientist at the Swiss Federal Institute of Technology and co-leader of the study, explained that this technology was designed for the most severe form of spinal cord injury. That means individuals with clinically complete spinal injury. No sensation, no movement in the legs, he stated. He also mentioned that the technology could be used for anyone with a spinal cord injury that occurred above the lower rib cage. So how exactly does this technology work? When the spinal cord is severed, the signals from the brain can't reach the target muscles, causing limbs to remain immobile and devoid of sensation. Currently, this condition is usually irreversible. However, the motor neurons below the injury site remain intact but inactive. To reactivate these muscle neurons, the research team used modified implants originally intended for pain management. Essentially, they repurposed an older technology used to block chronic pain by delivering electrical currents to neurons. This time, instead of blocking pain, the electrical currents stimulate muscle neurons, causing the muscles to move. The research paper notes that previous efforts targeted the dorsal column of the spinal cord, but this approach focuses on the spinal dorsal roots. The researchers believe this method would better restore diverse movements in the most severe cases of spinal injury. Delivering electrical currents to the muscle neurons is one thing, but it has to be done correctly. The system must simulate the brain's electrical messages precisely, timing the signals so that the patient's leg muscles contract in a coordinated manner that mimics a natural step. The paper describes this as a natural activation pattern. According to the research, targeting the individual dorsal roots with predefined timing can reproduce the natural activation pattern of motor neurons during walking. But how did they determine how to interface the system with the correct neurons within the body? It's quite fascinating. First, the team of scientists took MRI images of 27 spines and input this data into an algorithm. The algorithm produced a predictive model of the average spinal cord, including the size and layout of neurons. So, what is this magic algorithm? It's a program that has existed for a while called Sims for Life. This program can generate finite element models of the spine, map the nerve layouts, and simulate the voltages and electrical currents in the neurons. Amazingly, these predictions allowed them to test the feasibility of their systems without using live patients. Everything could be optimized and evaluated in simulation, which is pretty cool. After more tweaking and simulation, they finalized the design. Next, it was time to install the device. Neurosurgeons implanted 3 men with the device. All the participants had their spinal cords completely severed in separate motorbike accidents and were entirely paralyzed. After 10 days of recovery post-surgery, the men began training with the device and accompanying software. Amazingly, the software simulations proved to be accurate. All 3 participants regained some level of movement within just 1 day of activating the implant. This included being able to walk on a treadmill with weight support. One of the patients, Mikhail Rakati, said, "The first few steps were incredible, a dream come true. It wasn't just walking. The participants could also pedal a bicycle and perform squats. The device guided their muscles through all the movements." It's important to note that the patients aren't fully walking yet. However, Reggie Edgerton, an exercise physiologist at the University of California working on spinal cord injury solutions, told Nature. The next question is whether stimulation over a long time will help the motor neurons grow the correct connections to carry out the movements without stimulation. We'll have to wait and see. This could be significant if it comes to pass. Currently, the system has 16 electrodes, but a higher number of electrodes, say 32, could provide higher resolution movement. The team plans to move testing to the United States and has already received approval from the FDA. They will test the system in a US-based clinical trial with more participants. The researchers plan to focus on individuals with more recent injuries because tests in rodents have shown that animals tend to recover more motion when stimulation begins immediately after the injury. They are also testing a brain implant that would directly route mental instructions to the spinal cord stimulation machinery. This device might restore other functions lost due to spinal cord injury, such as bladder control. There's a lot of work being done in this area. As Reggie Edgerton says, this work will give many people with spinal cord injuries a reason to have hope, but there should be some caution. First of all, it remains an invasive spinal surgery, which comes with its risks. However, other scientists are working on a method that uses electrodes applied to the skin to activate the spinal neurons externally. This method would be cheaper and less risky. Mikhail Rakati is very happy with the results so far. He mentions that he uses the device every day for a couple of hours at work and in his home to do different kinds of things. Now, it has become a part of his daily life. He finds it beneficial, noting that working is super important, but just standing up can solve many problems in normal life. For instance, he can take a simple shower without crutches, standing up and using the shower. With the walker, he feels free and able to walk wherever he wants. At this moment, he is back to working, integrating the device into his routine. There are many patients around the world who need a treatment to combat paralysis. We have reached a point where we are ready to develop this treatment. We are collaborating with Onward Medical, which is developing the technology to turn these results into a treatment available worldwide. There you have it. We may have just witnessed the first steps toward a mobile life for those with severe spinal injuries. Recent advancements in spinal cord injury research are not limited to electrical stimulation alone. Scientists are exploring a variety of innovative approaches to further enhance the recovery process. One such approach involves the use of stem cells to regenerate damaged spinal cord tissues. Researchers are investigating how stem cells can be programmed to replace damaged neurons and support the growth of new neural pathways. By combining stem cell therapy with the existing electrical stimulation techniques, there is potential to significantly improve motor function and sensory perception in individuals with severe spinal cord injuries. This combined approach could pave the way for more comprehensive treatment options, offering a new lease on life for patients who have long been considered permanently paralyzed. Additionally, the development of wearable robotic exoskeletons is gaining traction as a complementary technology for spinal cord injury rehabilitation. These exoskeletons provide external support to assist individuals in standing, walking, and performing other movements. Integrated with the spinal cord stimulation devices, exoskeletons can help patients build muscle strength and relearn motor skills through guided physical therapy. This dual approach not only enhances the immediate mobility of patients, but also promotes long-term recovery by encouraging the natural reactivation of dormant neural circuits. As research continues, the combination of spinal cord implants, stem cell therapy, and robotic exoskeletons holds great promise for transforming the lives of those affected by spinal cord injuries, moving closer to the ultimate goal of full functional restoration. The development of spinal cord implants enabling movement in paraplegics marks a significant milestone in medical science. Successful clinical trials demonstrate this technology's potential to transform lives. While the journey to full mobility continues, progress is promising. Continued research and advancements could bring even greater improvements, offering hope to many. Collaboration between scientists and medical technology companies is paving the way for treatments that may soon be available globally, moving us closer to a future where paralysis is no longer permanent. If you enjoyed this video, subscribe for more content like this. So what do you guys think about this? Share your thoughts in the comments below. See you next time.